Hi everyone, today we're going to talk about centripetal force. This is going to be a review video, so it's going to go kind of quick. If you have trouble with it, please make sure you come see me so that you don't lose track of it later when it gets more difficult. Centripetal force is the force that is responsible for the centripetal acceleration. Since you know that F net equals ma, and you know that if there is an acceleration, there has to be a force associated with it. So our equation for centripetal force will be Fc equals m AC, which can be translated, since we know AC equals v squared over r, we can say that Fc equals mv squared over r. Now, the centripetal force is not its own force. Remember that you have, for many objects, you have to have contact in order for it to be an actual force. Again, that's not the case for gravity and the magnetic force, the electric force. However, for what we're dealing with right now, a lot of times we do have touching for forces. But the centripetal force is always caused by other forces. So the centripetal force can be caused by friction, it can be caused by tension, it can be caused by the normal force. Those are our three main ones, but it can be caused by a bunch of different things. When you're doing problems with a centripetal force, it is never an extra force. Usually it's going to be your net force. And so you're going to have other forces that are responsible for that centripetal force. It never just acts on its own. That's why, and excuse my language on this one, that's why I really hate when they use the term centrifugal force. I know, I'm sorry, I should bleep that out. But because that's not really an actual force. What you're feeling for that is inertia. Inertia wants to keep you moving in the same exact direction at the same exact velocity. You want to keep moving at the same way you're moving ahead of time. But instead, the vehicle or the vessel that you're moving in kind of butts up against you, and it changes your motion and it changes your direction. And so that's the force that you feel that's pushing you towards the outside. It is, we say, a fake force. Really, it's just inertia taking over. So the one I want you to be concerned about with is centripetal force, and that's the one that's pulling you in towards the center. So just like centripetal acceleration, centripetal force is always pointing towards the center of the circle as well. Now, if you had an object that was moving around in a circle, let's say counterclockwise, our centripetal force would point towards the center. Our centripetal acceleration would also point towards the center, because we know that our acceleration must be in the same direction as the force. But our velocity will always be tangent to the circle, no matter which direction they're acting in. If you were to let something go after spinning it in a circle, you would notice that if you're spinning it in a circle a bunch of times like this, like this, like this, and then you let it go, it's going to travel off in a straight line. Now, if this was a vertical circle, it would eventually follow a projectile motion sideways. If it is a horizontal circle, it's going to continue straight on moving in a straight path, because it's not affected by any outside force. Again, with a vertical circle, it would be affected by gravity eventually, and it would teeter off and become a projectile motion problem. But we'll do more with this in class, and that's about it. If you have any questions, please raise your hand and let me know.